from my mistake. All right, so here is a Khan Academy example. The original problem is 9x squared minus 36 over 2x to the third minus 4x squared. And then you're subtracting another rational expression, 3x to the third plus 5x squared over 10x squared. So working this out the same way as I did in my last video, I would start by factoring the denominator and getting the least common denominator. So if I factor my first denominator, I can see that I can factor out a 2x squared. So once I factor out a 2x squared, I have x minus 2 in parentheses. The 10x squared can really only be factored into 2 times 5. Now we could factor the x squared down into x times x, but since this also has an x squared, I'm just going to leave it as x squared. So now my least common denominator of these two original equations would have to have a 2. There's a 2 in both of them. It will have to have a 5, because this one has a 5. It has to have an x squared, because again, they both have an x squared, but it also has to have a factor of x minus 2. So the least common denominator of these original two fractions would be 10x squared times x minus 2. So my undefined values, or values that x cannot equal, would be 0 for the 10x squared, and x cannot equal 2 because of the factor of x minus 2. Okay, so then I went through and I proceeded to multiply my first fraction by the 5 and the second fraction by the x minus 2 and worked it out, and it didn't work out correctly. So what I want to show you is that sometimes if you look closely at the numerators, there are times when you can reduce the given fraction before you add or subtract. So looking at this numerator, I see that I can factor out a 9. Once I factor out the 9, I have x squared minus 4. Well, the x squared minus 4 is a difference of 2 squares and can be factored into x plus 2 and x minus 2. So this numerator now factored becomes 9 times x plus 2 times x minus 2. If I write the denominator in factored form, it's 2x squared times x minus 2. So if you notice, the numerator and denominator both have a common factor of x minus 2, which means that I can reduce that. So my new fraction now is 9 times x plus 2 in the numerator and 2x squared in the denominator. So that fraction is going to be a little bit easier to work with. So let's see, does the other fraction have something that can be simplified? So if I look at, oops, not equals, minus, well, let me use red again. So if I look, I bring down my minus at my numerator here, you can see that both terms have an x squared that I can factor out, which will give me 3x plus 5 in parentheses. And then over, I'm just going to multiply that back together, the 10x squared. So now that I've factored out this x squared, I have an x squared in my numerator and in my denominator, which can be reduced, making this fraction a little bit easier to work with, minus parentheses 3x plus 5 over 10. So now my denominators are just 2x squared and 10. So the least common denominator of these two now would be 10x squared. So I still will need to multiply my first fraction by 5 in the numerator and denominator in order to get the 10x squared in the denominator. So that would give me 45, and I could distribute that 45 to both terms. So 45x plus 90. And then the second fraction, I'm going to have to multiply the numerator and denominator by x squared. So I'm going to put that out front and out here. So, and I could distribute the negative with the x squared to both terms, and then just make this one big fraction. So the negative x squared times 3x would be negative 3x to the third. The negative x squared times 5 would be negative 5x squared. And then from here, you can see that there aren't any like terms, but we probably should put it in standard form and put the numerator terms in the right order. So negative 3x to the third, that 3 would go first, and then minus 5x squared plus 45x plus 90 all over 10x squared would be my simplified rational expression. So every once in a while, look to see if you can reduce within the fraction that you're adding or subtracting, like we did here with the x minus 2's and the x squareds. If you can, then you definitely want to do that to make your problem a lot easier.